look at cloud forensics and introduction. So we will look at various aspects. Of course, I was just joined towards the end of Dr. Satish Kumar's lecture, and he had discussed some of the cloud security and what is cloud and advantages, disadvantages, things like that. So let me share my slides and then we'll proceed further. Are the slides visible? Is the slide visible?
Yes, sir.
Yeah, let's proceed. So cloud forensics, when we look at cloud computing, we have realized a simple aspect that we can look at is that Google Drive is a cloud, right? Or maybe any banking software which is used across all the banks is a kind of a software as a service, right? So a lot of these resources that we have been using, maybe some of you are using Google Colab for research, which is a cloud environment, right? So these aspects. Hello. Yeah. Am I clear? There is some resound.
Sir, you are audible, sir.
Yeah. The others can be on mute then. Yeah. Sure. Thank you. So as we look at it, this is one report which I wanted to introduce to bring in why we are discussing cloud forensics here today, right? So when we look at the cloud adoption in India, this is Cloud Security Alliance, like Dr. Satish was also mentioning, like our DST, there is one agency in US where they are promoting Cloud Security Alliance, and Cloud Security Alliance wants to do a research in India, surprisingly. Right, it's I think 2-3 year old report, but it has a lot of value for us here to understand. You know, a lot of people how much of adoption is going on in cloud. As you look at it, almost 62% are active users. If you're looking at companies, they are effectively using cloud resources. That is something that is of interest, right? So as you look at the number of years, maybe I added 2 years here because the report is 2 years old. So more than 5 years, about 16%. About 4 to 5 years, it is 16.7%, and about 3 to 4 years or 3 to 5 years, it is about 35%. So in this aspect, if you look at it, so this is more than most of the people have at least spent 1 or 2 years in cloud already. Number of applications, as you look at it, if you look at it, there are more than 10 applications, 25%, and then at least 5 applications. If you say half of the companies have at least 5 applications, or 8 to 10 applications, or more than 10 applications in cloud. So that is something in India, and this is specifically to India. I can share the report towards the end of this thing. I will show you the report also. And then sir has also discussed public cloud, private cloud, and hybrid cloud. As you see, most of them would want to use a private cloud, 50%, and then of course hybrid cloud and public cloud is also used in India. We're talking about, right? And then the reasons for not adopting cloud, there are many reasons. But if you look at it, the people are not really worried about security because lack of industry standards, not cost effective. These are the major issues. And security issues are coming somewhere here. Risk of data loss and risk of security breach, they are coming towards the low part. It's not security is not a major concern as you look at it. Market dominance, these are the companies which are operating in India. Please note that this survey was in India. So AWS, Microsoft Azure, Google Cloud Computing is leading in India. And here I want to remind the government's policy, make in India. So do we have a cloud which is made in India? The challenge, one of the reasons why I want to take this talk today is to encourage you to just get in hands-on or get closer to technology. One of the things that is there is, do we really have a cloud, an Indian cloud, a Desi cloud? Do we have? So we don't have, right? In the leading these things. But then, fortunately, at least some companies have started, and then we have these 3 companies which have done something, and they have make in India clouds like NetMagic. The other one is Control S and InstaCompute from the Tata Group we have, but less market share that we look at. So NetMagic and so this is something which these are the Indian companies. In India, AWS is the biggest market share, but then of course the other also are there. And these are some security concerns as we look at it: data breach, right? Data loss, insider threat, malware injection, hijacking of attacks, denial of service attacks, insufficient due diligence, and then data in transit attack, man in the middle attacks. So maybe you can read through the report I will share with you. So I'm quickly skipping by. The other aspect that I wanted to highlight was, because we don't have a cloud, because we don't have a Desi cloud, can we make a Desi cloud? Of course, in fact, IIT Delhi has done a good experiment and they were successful. They have come up with a cloud called Badal. Badal is cloud in Hindi. So they have their own Badal. But how did they start? They started with some of these open source and proprietary software like these, and they have set up a Zen hypervisor and all, and then they've set up an OpenStack architecture. Later, they tried to build their own architecture, and then they converted that all these models they took out and they built their own software, and then they came up with their own version Badal, but not very active. Of course, we have an Indian called Rajkumar Bhuya, Professor Rajkumar Bhuya, who is a professor in Melbourne University. He has a software. He has built a software called Aneka. But of course, it is not made in India. It is made in Australia. In that sense, if you really look at, the company is based in Australia, right? So, but then this is how it is. So, what you can do if you ask me what can we do in cloud? So, the first thing that cloud needs is called a hypervisor. I will just briefly introduce what a cloud is also. So, what you need is a hypervisor, and the hypervisor is some of these examples that you can work with: Zen and KVM. Please download a Zen or a Zen server or a KVM. Sometimes KVM comes with Red Hat Enterprise Linux, RHEL. So you can take that, and then you can set it up, and then you can do that. So that's wonderful actually. So these are a lot of cloud service providers that servers also talking about, some brokers and all. So you have hardware. Of course, there are different companies which sell hardware. Then virtualization software. This is an interesting thing for cloud. We will shortly just briefly introduce you what it is. Then cloud platforms like OpenStack and VMware Cloud and other things. Then the platform as a service, which is hardware infrastructure as a service, Amazon Web Services. Then you have platform as a service, which is Azure and Salesforce.com. Then you have what you call software as a service, Google App Engine, and then you have NetSuite or Salesforce. And then you can request somebody to manage cloud for you. There are some people who manage cloud for you. You can actually buy a cloud from somewhere, services from somewhere. The management services you can buy from cloud broker. You can buy an entire cloud. These are some companies which they give you entire cloud. So this is slightly in the bigger screen. So there are public service providers, as Sir was also already mentioning. Dr. Satish had mentioned. So you have the Google Cloud, Azure Cloud, EC2, Bluemix, Salesforce, Rackford. And then these are our Indian cloud service providers, as I had mentioned, NetMagic. A lot of companies use NetMagic, and ControlS is there, and InstaCompute is there. Now, what is a cloud? If you look at it, cloud is a lot of resources are virtualized. The key word that you should understand is virtualization. When we talk about a hypervisor, it is nothing but a virtualization software. You would have heard virtualization software. In fact, earlier, the first time you would have heard about virtualization was through the Java Virtual Machine, JVM. So Java Virtual Machine is slightly where bytecodes are created, and one bytecode can be created on one machine and can be executed on another machine. So how does that do that? Java Virtual Machine facilitates that. In a similar sense, here I can run two operating systems at the same time. Who facilitates that? It is the virtual machine. So what happens is all the physical infrastructure gets virtualized, and on top of that you run applications, and you run a cloud management software that becomes a cloud. So if you look at this is how a data center looks like. A cloud background. If you look at behind the cloud, what is there is a data center. On one side there are a lot of servers. On the other side there is a storage, and they're all connected by fiber optic cables. Here also you'll see a lot of cables connecting that, and then the size of the individual, if you see, that's the size of a cloud, right? And then so many servers, so much of storage is kept. So this is our if a data center, if I look at it as a block diagram, this is how it look like. Now what you do is you virtualize it. And how do you virtualize it? So you virtualize the storage, you virtualize the network, you virtualize the compute is the servers. So you have only cores or processors at that level, and then your applications and all that. So that is a virtualized data center. Now the virtualized data center, once you add the cloud services, it becomes a cloud. That's all. That's how I want to introduce cloud to you, right? Now, what does virtualization help? Virtualization is a layer which sits in between the hardware and the multiple operating systems or the multiple virtual machines that run. So because of this software, there is one system. Earlier, you had one processor and one network interface card, one RAM and one hard disk. You could set up one operating system, or you could set up two operating systems, but you could do dual partitioning. Either one will work, right? Either Ubuntu will work or Windows will work. Both of them cannot work at the same time. So somebody thought immediately, why not make it work? Why not make both of them work? So then he went into what is called virtualization layer. And VMware, in fact, pioneered this thing, right? Then you have this, before virtualization, only one application, or one operating system and multiple applications. But here now you can run multiple virtual machines on a hypervisor on a single hardware. So that's the advantage of virtualization. What is a hypervisor? Hypervisor sits on between the hardware, and sometimes you have the operating system, some you don't have the operating system. So you have two types of hypervisors. That is called bare type 1 bare metal hypervisor, and type 2 is called the hosted hypervisor. Hosted hypervisor, first you install the operating system on that. On top of that, you install hypervisor. This is what most of you would have done, right? You would have had a Windows machine. On top of that, you had VirtualBox set up here. On VirtualBox, you would have created virtual machines. But there is another type of hypervisor called, let us say, Zen server or KVM, which can directly be installed on the hardware. So this acts as an operating system also, and then you can run multiple virtual machines. So we in our own institute, we try to simulate and emulate. That's why I said we set up what was called Zen hypervisor, and then the Zen hypervisor, we used to build what is called what is the OpenStack model. The OpenStack software we have used. So this is a temporary or what you call a block diagram representation of an OpenStack architecture. OpenStack architecture has two fixed servers. One server is called the controller server. The other server is called the what's called the networking server. Two servers are essential. And after that, you can have any number of compute servers. So if there are 10 machines with us, 10 servers with me, 2 servers will go to become controller server and networking server, and then you have 8 computing nodes. If they have 20, these 2 will go, and then the remaining 18 can be servers, and they can also be on a network. So here we have 3 networks. One network is the management network. One network is the what is called the tenant network, and the third one is an external network. External network is where the cloud is connecting to the world. The cloud is connecting to the world. That's an external network. So, and then you have an internal network, which is the tenant network, which is the connection between hypervisors and virtual machines, where traffic comes in. They come to the port here, they enter the network system, then they come into the network, and then they go onto the address of the other tenant virtual machine. So they are connected. There's another network called management network. Management network connects all the networking and compute devices, and also this time the controller is also added. So this is how a bigger picture will look like that. And then some of the numbers are mentioned there. So maybe you can go through my paper with my student on intrusion detection in cloud. You will be able to see most of these attacks and most of this description. In fact, this diagram is taken from there. So because of lack of time, I'm just skipping this portion. I will share the paper also in case you want. You can refer to that paper and then read through all the attacks that Dr. Satish had mentioned, and also what I'm going to mention. So these are numbers here. So each of these numbers have one meaning, and then you can refer to the paper. Because of lack of time, I'm just wanting to move on. These are the various types of attacks which are there on the cloud environment. And then you see there are attacks at the virtual machine level and virtual machine monitor level. There is attacks on the hardware level. There is attack on the storage level. There is attack on the tenant network. So these are various types of attacks which are there, and maybe you can look at the diagram in a slightly bigger sense. Then you will be able to see it. Then you have these layers here: network layer, storage layer, hardware layer. Then you have the virtualization layer, that is the hypervisor layer, and on top of that you have the virtual machine layer, right? So different attacks can happen in the cyber security, and I think one of the attack that Sir had discussed was side channel attacks, which are cross VM side channel attacks. And the second one is regarding this thing that is hyperjacking here, right? So these are the attacks. So please read through that paper. You will be able to get through most of these concepts here. And then this is what cloud security is. So most of you can look at that. There is a small mistake in this diagram. If you look at it, very closely, you will understand here you have hardware called cloud hardware. But then cloud hardware, what is the storage then? Is this software or anything elsewhere or something? Yeah. What is network? Is it hardware, software, or a platform? What it is? So in effect, really, all these three things are hardware only, right? So the hardware here we are talking about was the hardware which directly is part of the system. Then storage is attached. The network is also attached. It has a lot of the switches and all that. So that's how you can look at the three things. So these three things should have been drawn like this: 1, 2, 3, and then you could go to the application layer attack. So variety of attacks. Some of them you would have studied, some of them would have known. So if you're interested, you can look at that. So let me introduce, because one of the important organizations, sir had also mentioned, Dr. Satish has also mentioned NIST, right? National Institute of Standards and Technology, and they have a reference architecture which they have given, and then there are various concerns that we tend to look at, right? So you have a cloud broker. Cloud broker has these three major roles, that is service intermediation and service aggregation and service, arbitrage, right? So if there is any complaint or something, so that's what a cloud broker does. Then the cloud provider has this thing that he does the orchestration, cloud orchestration you would have studied. And then you have the SaaS, PaaS, and as their service layers. Then the resource allocation, resource abstraction and control layer. The physical layer is also there, which is talking about the hardware and facilities. But then there is a cloud service management. Service management is who wants what kind of service and how much will it cost, how long will you keep it. So you have the business support, you have the provisioning and configuring probability and portability and interoperability that is there as part of the cloud provider. You have the cloud consumer who will consume the data, and the cloud auditor who will try to ensure that he does the security audit, provides band impact audit, and performance audit. So all these audits will be done by the cloud auditor, right? So that's that, and then cloud carrier, which carries different kinds of network symbols that are there. Then there is another architecture called cloud computing, trusted cloud initiative, TCI. This was promoted by Cloud Security Alliance. So as you see, basically, if you are able to look at, this is a security framework, there is a SPI framework, and there is an IT audit framework, and there's a legislative framework. The equivalent terms related to this would have been what is called, the IT reference auditing and security architecture, and then you also have service management architecture, that is ITIL, and then you have SABSA. So these are the kinds of architectures that are there. But let us correlate these security frameworks, right? Legislative framework, IIT framework, and also you have the security framework, right? So that is the equivalent 4 components that are given to cloud. So if you look at it, you have course delivery, which talks about software as a service, framework as a service, and what you call infrastructure as a service. But at the same time, there is this cloud operations, which are public, private, and hybrid. And then there is a cloud trust. So governance issues will be there, identity issues will be there, authentication issues will be there, authorization issues will be there, auditability issues will be there. All these are part of the cloud initiative, trusted cloud initiative architecture. Then we move on. This is the broad outline of the CSA trusted cloud initiative architecture. It won't fit the screen actually. It won't fit any slide. That's a huge this thing, right? And each of these 4 layers here: infrastructure services, information services, application service, and presentation services. The huge blocks. And then here you have the security risk, and here you have information technology operation services. This is ITOS, and you can also look at the business operations. So let me show you this TCI architecture, because it doesn't fit the slides. So let me share, unshare my screen, and then let me share again. And this time I will share you. Yeah, this is the TCI reference architecture. Are you able to see? Is it visible?
Yes, sir.
Yes, sir.
Yeah, sure. So here, those 4 diagrams, as you see it, you had 4 diagrams, right? So you have one business operation support services, the information technology operation and services, operation and support, and presentation services, application services, information services, and infrastructure process. And then here you have security and risk under that heading. You have privilege management. So some of these techniques are mentioned. Okay, so let me increase the size. So business operation, as you look at. Okay, so business support operations, as you see, it is compliance, data governance, operation risk management, human resource security, security monitoring services, legal services. So this was the first business, what do you call, BOSS, business operation support system. Then you have information technology, operations and support. So you have the IT operation, which is done by resource management, portfolio management and all. Select security, service delivery. So that is another issue that is there. So you have the IT operation, you have the service delivery at the IT resiliency. These are some aspects that you do. And lastly, you have service support, configuration management, incident management, problem management, knowledge management, and all these. So this is one more layer that we talk about. The 2 layers. After that, sorry, this is some issue with the laptop. Yeah. Then you have the major chunk, which is different layers. So here you see the infrastructure services. So different services are taken. Infrastructure is provided. And after that, you have information services, that is reporting, service reporting, data governance, security monitoring. All these things are done here, right? So this is information security, information services. Then above it is the application services, different interfaces, security knowledge lifecycle, and then proper cost estimation and all, development process. This is one. And lastly, you have the presentation service, presentation modality, and presentation platform. How do you present the things? So as we move to the last layer is the security and risk. You have the compliance risk and governance risk and compliance. You have InfoSec management, public management interface. Then you have the threat and vulnerability management, infrastructure protection services, and data protection. Okay, and policies and standards. As you see this here, here you have these concepts, which are storage virtualization, network virtualization, server virtualization, right? And these things, desktop applications, that is there. So desktop client virtualization is there. And on the other side also you have facilities, right? Control physical access and all that you need to do. So infrastructure level. So what are the levels in which you can try to do that? Is one is infrastructure level, one is information level, one is application level, and the other one is presentation layer. So this is how the NIST document has been updated by these research scholars who are basically picked up by volunteers from various countries, and then you do that. So Dr. Anand was part of that internship where he could go and spend some time and understand. So similarly, we had participated in this work group, which created another architecture also. So this was over telecon. We had to join through Skype and all. So that was the basic thought process. So let me go back to the slides. So you have seen the broad architecture of slides, right? So how it looks like and all that. So we are able to try to look at that, right? Yeah, so this is these are the 5 layers that we try to decide, but yeah, let me take you there. So this is the business operation support services, infrastructure technology support services. The infrastructure services are less compared to what it was. So presentation, application status, network layer, and then you have infrastructure, right? So there were different work groups who developed these things. So and then they came forward. So this is how the big picture that I've shown will fit in here. Simpler versions are given also. Then this cloud forensics capability maturity model. These also I will share the slides. So there are 5 levels, right? So the 5 level, one is initial, second one is repeatable, third one is well defined, managed, and then last one is optimized. So how are we ever going to do this is what is the initial step. There is some storage space required, there is some computational space required. How do we do this is the first step, initial step. The second capability level is how can we ever done in this before. So that is one thing, repeatable. Third one is defined, which talk about what is the process for doing this, right? So how much is defined, managed, what resources did this require, or whatever money is there, along with that we can do something, but what are the other resources that you have. Then last one you have optimizing is how can't we do this the better, right? So this is the model, capability maturity model: preparation, identification and scoping, containment and intelligence gathering, then exclusionism, and then you have the last part, right? The last part is where follow-up lessons learned. So this is usually an architecture. You collect the data, you preserve the data, then you examine the data, then you analyze the data, and then you find out if there is any rogue method that is available presently in the network, right? So what you need to do, you need to do network forensics a little bit. Cloud forensics involves network forensics. Cloud is also a network in that sense. Then you have to do timeline analysis. A lot of data gets stored, a lot of data needs to be evaluated. And we also have file systems. That is, if somebody creates a cloud environment and he deletes the files, but the files are not deleted, the ones and zeros do exist. So the file can be copied or carved even if the system has been formatted multiple times, right? So then there is a data recovery issue also. So some of these things you can try to do. You can give alarms for what is that memory or network forensics, we give that. And then similarly latex management and firewall, you will get it. And then we get VM snapshots. What is VM snapshot? Recently in the lecture, sir was announcing that a live virtual machine can be migrated. Live virtual machine migration is what it is called. How does the live virtual machine migration work? So first you take a photograph, what is a Xerox copy of the existing virtual machine. How do you do that? You do that in a concept called snapshot. So the entire memory is copied. If you look at it, how does a file get stored? How does a a virtual machine get stored in the system? So it is nothing but a file, right? So it is nothing but a file which is created. It will run like an operating system when you have a software called VMware or any others, VMware, VirtualBox, anything, you can do that, right? So the point is we try to do that. And then there are the questions at the provider level. So you can go and check whether the security provisions operations center is there or not, cloud service management platforms, what are the issues there. And so these 3 things can be done. So you have the incident response team, which is continuously monitoring the systems. And then you have a forensic methodology, which is given. And then you have variety of alarms, notifications, VM snapshots. So in the case of VM snapshot, you take the snapshot of the memory, and then you, in a high speed network, you shift it. So it doesn't take much time before the virtual machine can be moved to another location, and the server can be shut down, because if only one system or 2 systems are meeting, we can ask them to go to their respective locations, right? So this is something that we can do. So this is the capability map. So now this is the background which I wanted to give before I move into forensics, because forensics, computer security, most of you would have heard. Computer forensics or cloud forensics may be very new term to you. It's the process of identifying, preserving, analyzing, and presenting digital evidence in a manner that is legally honored. So you have to answer questions. I will come to these questions again. The capability maturity model also talks about these 5 questions: what, where, when. But then he also used the mechanism, right? So what, where, how, capturing and storing data. So usually somebody is working on a system, we don't have access to everything. Let us say he is using a cafe where identity is not checked. So he can go every day and send an attack, launch an attack, and then it becomes very difficult. So capturing somebody who is doing the attack may be different, but at least we'll be able to provide the network from which the attack has originated, what, where, it, how. So capturing and data. So you carried out in the least intrusive manner. So you don't disturb the whole mechanism. The virtual machine doesn't even know that some data from it is being taken, right? Analysis, processing, and implementation of data collection and upon in a quote of time. So you have to ensure that the original is preserved, a copy of the original is made, and that shows these particular things. So that is something which can be done. So first is you have to identify what has to be preserved, what has to be collected. Second, what has to be preserved. Third is where are we going. So this is something that we can look at. So what, where, and in fact, if you look at 3 points, you'll remember easily. Once when we come to that definition, I will tell you. So computer forensics deals with latent evidence, that is not active evidence, not live evidence. It is only always stored evidence, or it is latent evidence, right? So there is no scientific knowledge for clipping the collecting, analyzing, and preserving evidence to the courts, the legal system, right? So you have to give it in the system that they agree and that they will. So analyze the data from computer systems, memory, hard disk, cache, OS logs, temporary files, and downloads. But then, so we need to correlate that. So that was computer forensics. Computer forensics deals with mostly hard disk based analysis, right? And then sometimes you can have cache and other things also. Now, when we slowly move from computer forensics to network forensics, what was the difference? The difference was that you need to capture, storage, store, alumni, manage. So these things you can look at, right? So the capturing, storing, examining, correlating, and analyzing network. So formal, multiple, actively processing and transmitting digital sources and security sensors. That is what is network forensics defined as. The analysis results in developing and detecting and characterizing unauthorized network events meant to disrupt, corrupt, or compromise system components. Because this is how I would say we would look at, right? So this is one important aspect, right? Secondly, assist in incident response and to recover from system compromise or disruption of services. That is what is network. So network connectivity, network interaction is what is network forensics. So we move into cloud. Cloud, there is an attacker who is attacking a cloud client, and the cloud client is accessing the data from that. So once he has successfully compromised the cloud client, he has a direct attack. He doesn't have to come this way. Once he compromises, he knows the number. So that's how the cloud thing. So now we are coming as a forensic investigator, right? Cloud forensics is the other side of security, I would call it, right? So that is something that we must understand. So application of digital forensics in cloud computing, that is something which is used. So cloud forensics is happening. First session, I think Dr. Gaurav Gupta would have shared about what you call digital forensics in cloud computing environment. So I'm sure he would have explained some concepts and some books as well. So to reconstruct the past events in cloud computing. So unless and until logs are maintained for last 6 months, we don't know how to reconstruct the past events. Maybe we are investigating a case and then we find out that something happened here, something happened here. So we want to reconstruct the past event. So that is hybrid forensic approach. So you can do it on remotely, you can do it virtually, you can do it network, you can do it on live, you can do it on large scale threat client. So these are some things which we can look at, right? So interaction among cloud actors, as we said, cloud provider, cloud consumer, cloud broker, cloud carrier, cloud auditor, all of them are there, and then multi-jurisdictional and multi-tenant solutions are a problem in cloud forensics. So two things. One thing is you can use cloud to solve a forensic problem. Then also, though it is not a cloud forensics, you use cloud for forensics, right? So forensics as a service is another software which has come up. You can type Google and check out the names. I'm forgetting now. So what do you say? This is what is cloud forensics, right? So then applying digital forensics for cloud forensics. Secondly, it will be pure cloud forensics if the deliverance panel, what do you say, the court that is there, the hybrid forensic approach that we have. So once we have the forensic digital forensics applied, the resources are given by cloud. Secondly, we need to identify forensics in the cloud, like I was talking about forensics as a service. So you have forensics as a service running somewhere. So it is not cloud forensics, but you are running forensic service on the cloud, or you are doing digital forensics using cloud resources. That is, you are using cloud computing to do forensics, but that is not cloud forensics. Now, if you do forensics in the cloud, you go into a cloud environment and you do within the cloud on the cloud components, right? So then it is called a cloud forensics, right? In fact, I will try to differentiate cloud forensics and cloud security also shortly, right? So sometimes you will have to give multi-jurisdictional and multi-tenant solutions as well. So if you look at the major difference between security and forensics, what is security, what is forensics, right? So let me give you an example here. What is security and what is forensics? So if you look at, if you go to an ATM, right? There's a board there saying that you are under camera surveillance, right? If you go to bank, they say that you are under camera surveillance. If you go to some major office, corporate office, you say they have boards which says you are under surveillance. So security, what it can do is it protects the system against attack. Security protects the system against attack. What about forensics? Forensics does not protect the system. Forensics wants the attack to be successful because I can get information about how the attack happened, how I can get some information and all that. That is what is forensics. So it does not stop the attack. If it stops the attack, it can't investigate it, right? So the point is there are two advantages of handling these cloud environments. One thing is you can what you call you can stop the attack and you can be happy, but then most of the time you should be able to allow the attack and later investigate the logs that have been collected. So usually security is in real time because 24/7 you have to check the security monitor. But then if you look at I was giving you the example of a surveillance shop, right? Wherever you go, there are boards which are having these surveillance boards. So what do you do when you go to a shop? Do you steal there? Because you know that there are cameras everywhere, right? Or camera is on you, and then you don't do it, right? So you don't do the attack because there is some precautions which have been set. So that is what is forensics. Forensics makes you see that, notice that what do you say? You are under आप camera के नजर में, you are under the observation, or you are under your computer surveillance is there on you, right? So if such a surveillance notice is not there, then you will have the freedom to do it. So usually forensics, what it does is it reduces the kind of attacks that can happen. So security, as I mentioned, is in real time, but forensics is post-mortem, after the attack is open. That is why we want the attack to happen. So attack happens, maybe the patient may die, but then you know why the patient died. You do the investigations and then you can conclude. Of course, so that's the kind of thing between security and privacy, right? Security is generalized, looks for possible harmful behaviors if there is this thing. So people look at you have to look for all possible harmful behaviors, and then forensics is case restricted. See, whenever the attack happens, then only the forensic investigator is called. He can sleep most of the time. right? When an attack happens, after the attack data is collected, then only the forensic investigator is called. But a security expert will have to be there 24/7 and engage with them, right? So you have to keep alert 24 hours of the day. And then forensics, it's a very time-bound process, right? So after every crime notification, it's called notitia criminis. Then only the work will start, right? So security is an established field. Forensics is very young science. So if we look at cloud security versus cloud forensics, the definition, the discipline, these are the subjects which can come under these things. So you have the discipline, then you have the problem, lack of data safeguards and compliance standards in cloud security. And evidence is generally characterized by its fragility and volatility, right? So that is something is another issue, because what you need is live, real-time clouds are required, right? And the challenges, the notorious 9 cloud computing challenges, top threats are there. I will share that slowly. Those are the challenges, but NIST has 9 challenges. These are the work groups which are there. So if you are interested, you can join one of them, right? So I will share some of the material, and in the end of the material, there are some email IDs where you would like to join. So CSA, as I was just mentioning, the notorious 9 comes up from this. It comes from the Cloud Security Alliance. So there are the notorious 9 attacks that are there are data breaches, data loss, account hijacking, insecure APIs, the denial of service attack, the malicious insiders, abuse and nefarious use, and insufficient due diligence, and then lastly shared technologies use. The CSA formed a working group also, and then they are working on incident management and cloud environments, multi-jurisdictional issues. That is, data is abroad and your application is in India. They are in multiple jurisdiction. If something happens there, how do we verify it? That's an issue. SLA for forensic support, service level agreements, and forensic ready virtual cloud environments are also there. Chain of custody, forensics as a service, these are issues. Then, of course, obviously, you can follow the ISO 27037 mapping, which talks about the identification, collection, acquisition, preservation of digital forensic, which is basically a model. Now, along with the notorious 9, you have the forensic science work group, the NIST's cloud computing. So the 9 challenges that we can look at, NIST cloud computing forensic science work group. Earlier, we saw what was the cloud security alliance. Now we have the cloud computing forensic science work group of the NIST. It also has 9 challenges. These are 9 attacks. Now these are 9 challenges. And these 9 challenges are divided into 65 challenges. There's a small booklet, or what do you say, a PDF file by NIST. You can visit that, and then you can try to look at that aspect also. Now the architecture, there is diversity, complexity, provenance, multi-tenancy, data segregation. That is the architecture. These are the issues. Diversity, multiple hardware may be there, complexity in virtualizing all of them. Provenance is being prepared, being ready, right? Readiness is another word that can be used instead of provenance. So if your architecture, if there are no software which is able to recognize some kind of data, or you have a mechanism like surveillance, right? Then only you can actually catch the attacker, right? So you need to prepare for the attack. You should not only start working after the react. The point is lost, right? So you have to do it. You have to be ready. So that is what is called provenance. Multi-tenancy is multiple systems. We all are there, and then there may be a question. Data segregation, also keeping the data isolated from one another, right? So second aspect is data collection. So data integrity, data recovery, data logging, and imaging. All these come under the part of data collection. There are challenges of trying to take data and send it to another place. But in case of lastly analysis, not the third one is analysis, correlation, reconstruction, time synchronization, log meta, and timelines will be decided in the analysis. Anti-forensics is forensics is where you prepare to catch the thief. Now, what is the thief doing? He knows that you will catch him. So what he does is he tries to do anti-forensics. Anti-forensics means whatever you are trying to collect, he will feed wrong data to it, right? That is something that you can look at, right? So now what is required? Not anti-forensics, but anti-forensics, right? Anti-forensics is forensics will fail. That is anti-forensics. Anti-forensics is forensics will be stagnant. So we have to think what the attacker will attack, and accordingly we have to modify, and then we have to bring in the anti-forensics. So that is what is there. So there is obfuscation, data hiding, malware attacks can be handled. Then incident first responders, trustworthiness of cloud providers, response time and reconstruction of attacks will give the incident first responders a trustworthiness. Then you have the legal aspect, that is jurisdiction, laws, science, service level agreements, contracts. There may be subheads, right? International cooperation, because the one attack may be in one state and the other one may be the other one. So you have seen the first three, that is architecture, data collection and analysis. So usually, mostly this is the normal trend, that first you collect the data, then you analyze the data, and then you address the data. In between there are some questions, right? So here you have anti-forensics, incident first response, legal issues. Lastly, you have last three, that is role management, data owners, identity management, and users and access controls. Then there are standards, standard operating procedures, interoperability aspects, right? So standard operating procedures, interoperability, testing, validation can be handled by the standards. A lot of standards are required. These are challenges. These are the challenges that we can look at. And training, forensic investigators, cloud providers, required qualification and certification. Training is required, right? So these are some manual things which can be done, but architecture can be given, data collection, analysis, carefully getting the data using anti-forensics and anti-cell response. So this is how we can proceed further with the 9 challenges. These 9 challenges are built into 65 challenges. You can look at those 65 challenges. Also, there is separately a published paper which is available on cloud forensics, specific on cloud forensics. So then later there was a cloud computing workshop was also held, the cloud forensic reference architecture, root of trust, e-discovery. So deletion in the cloud, lack of transparency, timestamp synchronization, use of metadata, multiple vendors, multiple venues and geolocations, data integrity and evidence problems. So these are issues in case of cloud computing workshop which they did. So this is what, let me show you cloud forensics, which basically works on hypervisor. There are some cloud services, the cloud hypervisor is there, and then you have the physical hardware which is there, and on top of that there's a cloud computing, right? So this is first level, but then when you want to do security, security is when you have the cloud computing, you have the cloud services, hypervisor and hardware. Then you have cloud security, which we discussed. Dr. Satish had mentioned some of these. Then you have cloud attacks, which these security aspects. So these are the CSA's 9 attacks that are mentioned here. Then the cloud forensics is where you do acquisition, that is collection, analysis. Before analysis, you can do an examination also, and then you can approve, right? So these are the 9 attacks, and then you come up with the cloud forensic framework, and then cloud anti-forensics or anti-forensic framework. So to ensure that these attacks get wrong values, you tend to do this also. So finally, cloud anti-forensics. So not only cloud forensics, but cloud anti-forensics is the highest level of forensics that we can think of. So existing cloud models, there are various literature. We published the paper in 2010. So 2015 till 2015, what the other paper should say. So that is one. So you have the preparation, detection, collection. So preparation is provenance or readiness. Detection and collection is collection or acquisition, and then you have presentation, not very keen, but you have the examination and analysis of the both have to be done. So the attack data is collected, and you have to analyze and investigate the thing, and then finally you can make the presentation. So in the other models which are proposed at that time, there was some were having full, some were not having. So this disparity be existing cloud this thing. So finally, you have identification. You try to identify the problem. Then you either go for acquisition or you go for collection, and then you get the data to you. And later you can do the identification can be slowly performed. Right. So Ruan is another very popular scientist as a faculty. Kevin Ruan. She has proposed in her research paper 2013 that this can be a good model, right? So what we were discussing, what we were talking in the previous slide is this part. Right, so if you are able to go through identity management, anyway, I'll share the slide so later you can go back, event management, identity management, encryption management, interoperability management, and then you have the collection, analysis, and examination being done here, and later the results will be supplied with everybody. So we simplified the process. We said acquisition, analysis, and attribution. So I will, I think one of them, Dr. Anand will handle the acquisition part, and Dr. Pankaj Kesaravani will be handling the analysis part. He will talk about some machine learning algorithms, some deep learning algorithms applied in cloud forensics. And lastly, I will again come back to you maybe day after tomorrow and discuss on attribution. Attribution is where somebody has the origin, finding the origin of the attack is attribution. So after finding the attack, we should find out who has done it and all, and finally we'll be able to do this. So because digitally you can't track to the individual, it's not possible. Any amount of digital technology will not help you. So hence using cloud computing for evaluating huge data sets. So I think that is where cloud is working. But then slowly the time is changing where we are going behind. So now, before I go into this process, so let me stop here. If there are any questions, then I'll come back to this part, right? So, or let me complete, and then we will take some questions. And then again, if there is something else I would like to show you, right? So till now, are there any questions here? Let me stop. Let me give a break.
Participants, you may unmute and ask the question from the sir directly.
Sir, good afternoon, sir.
Yes.
Sir, can you give any case study on this? Any incidental things on this cloud forensic?
Yeah, actually, one malware analysis can be done very easily. So most of the papers we have not actually set up a cloud and launched an attack. We have set up a model of the hypervisor, because whatever happens on the hypervisor is actually happening in the cloud. So that argument, of course, maybe till some years ago things were not very advanced, and hence it was difficult. But these days, you may be told that why don't you set up an OpenStack cloud or a cloud stack cloud? There are different softwares which are there. Why don't you set up a cloud yourself? Take 10 machines, set up a cloud, and then check it out, right? But otherwise, we were working on the hypervisors, and we used to run some malwares, get some data collected from that, and then do the cleaning, and then we used to do the data analysis. Maybe apply machine learning or something, and then you can do. So you may later get a data set also, and then you can say that this kind of data gets collected. So this is corresponding to this kind of data. The data may be different. The data sets may be different. You may collect a small data set and say that this is the kind of data, and you may take a similar bigger data set and build a strong machine learning algorithm or deep learning algorithm. That is usually the trend that is happening. And then you share that these results can be applied. Once the classifier is built, you can run it here as well. So that is something that you can try to look at. But then there are many challenges in doing. It's not very easy. But at least at hypervisor level, definitely you can do it. I will shortly introduce you to a tool called Virtual Machine Introspection, VMI tool. It was maybe the work of a PhD student, and he developed the virtual machine introspection tool. But then it has produced many PhDs later. The tool itself was used by many researchers. In fact, we also have used extensively virtual machine introspection, and we are able to get good results. So that is something that we would like to say. Yeah, hopefully I have answered.
Yes, sir. Thank you.
You can try what is that? You can try hyperjacking, or because you will need to work out what is called you will need to work out the complete attack, and it is not very easy. And as we look at it, most of the attacks we have discussed are based on some vulnerabilities, and those vulnerabilities do not exist now, because once the vulnerability has been found out and people have told, people have plugged in that vulnerability, and now that vulnerability doesn't exist. So that is something. So one more thing, recently we did one more attack on the VM, right? So some of these normal small level attacks can be done, and you can do that, right? So those kind of attacks can be run, right? And then you can find out, observe, and accordingly, because there is no cloud data set which is available, any attack data set on the cloud. So all data sets which work on hypervisors or on the KVM or Zen, you can use that to build a forensics model, right? So that's the solution that you can give. And of course, things are moving up now. You have what is called Docker or containers coming up. The lightweight hypervisor, I would call it, or lightweight virtual machines, I would call it. Containers are lightweight virtual machines. They don't have an operating system. They will run as a kernel, or as a, not a kernel is not a word, as a small container of applications, which applications can run, and it can contain the required these things. So that is something. Yeah. Shall I continue?
Yes, sir. Good evening, sir. I have one query.
Yeah.
Sir, suppose I'm deploying a private cloud in an organization. So generally, sir, I will use the private IP address.
Yeah.
So, sir, which one is the topmost attack are possible at the private cloud in an organization?
In a
Suppose I'm deploying a private cloud, OpenStack, anyone. So
okay.
which one is basically topmost type of attack are possible during the virtualization?
Insider attacks are there, and okay, let me share that slide and then describe. So what are the attacks that are possible? Yeah. So on the virtual machine level or the hypervisor level, you have hypervisor. You can have a rogue hypervisor called hyperjacking, or you can have a backdoor which can be there as a part of the hypervisor, or you can inject a malware or a hypervisor data, what you call distributed denial of service attack can happen. You can have VM escape attack. This is what I asked, or VM sprawling, creating more VMs, right? One VM creating another VM. Okay, malware injection is anyway there, or attacks on web applications. All these things can happen. Cross VM side channel. Side channel is not the main channel. The main channel is the packets, but the side channel is the temperature, the heat, the kind of software that you are using. All those information can be there. So these are attacks which can happen. And on this, the guest denial of service attack. So sometimes you have all the guests which are installed, the virtual machines are attacked, and the virtual machine is compromised, right? So these are something. So VM escape, VM sprawling can be found out. These can be the common attacks, whatever. Now, if you ask me what are the attacks at the virtualization layer in this big diagram, as you see, so these are virtualization layer. They have crossed virtualization layer. All attacks which are coming beyond this are attacks which are in the virtualization layer, right? So what is the difference between, in simple terms, what is the difference between cloud security and cloud forensics, right? So or network security and cloud security. So that's another important question. So if I look at that answer, how do you answer what is difference between network, because cloud is also a network, right? So there are multiple networks here, there are servers here, the servers are connected by network switches, so obviously it's also a network. So if cloud is a network, then if you launch an attack on the cloud, it becomes network security. But what differentiates network security and cloud security? The difference is you need to cross the virtualization layer. If you don't touch the virtualization layer, it is the network security only. If you cross the virtualization layer, then it is called cloud security. So similarly, if you do network forensics, then you don't have to do anything. You do it at the switch level or on the cable level or the hub level or the router level. You try to make changes. So that is what is network forensics. But then if you cross, in fact, maybe I'm not sure if you have been introduced, virtual networks, right? There is a switch that is called open virtual switch. Like let us say I have these what is called tenant network. What is this tenant network? Tenant network is these two systems which are together. They are on one tenant network. One tenant network means they both are running as a separate network. So there are virtual machines and there is a network of virtual machines. How is network of virtual machines maintained? What they do is you try to create a switch. A very good example is what is called open virtual switch, OVS. Okay, you can go and search openvirtualswitch.com or ovs.com, and then you can download the software. So what you can do, you first have to set up the hypervisor. Try this as an example, as an exercise. What you need to do, first you need to set up the hypervisor. On top of the hypervisor, you need to set up the open virtual switch, then create 3 virtual machines. Try to create a network among these 3 virtual machines using that tool called this thing. So that's how we will be able to do it. So in a similar sense, anything that crosses the hypervisor is said to be a cloud attack. Now, when you look at these diagrams, you have Ethernet cards here. These are Ethernet cards. Whenever there is a connectivity, it's called an Ethernet card. So now from this outside network, if things are coming in, outside network things are coming in, first it has to go to the network server. And network server does the authentication. Once the authentication is done, it comes onto this network, finds the location, and before it doesn't go like this. So what happens? It goes through hardware. From the hardware, it comes to the hypervisor. From the hypervisor, it comes to this thing. So here, the hardware of the hardware that has been given to you, that becomes very important. So first you have to come from the network, you have come to the hardware, and then you have to come to the hypervisor. Here, hypervisor, you can do anything that you would like to do. So that is something which is possible, right? So this is how you can try to look at various kinds of attacks. Yeah. Any more questions?
Sir, some questions are there in the chat box.
Okay. Let me check. How integrity forensics can be processed. Okay, as of now, if there are some encrypted data or if there is some data which cannot be evaluated, that's the challenge. Encrypted traffic, very difficult to do forensics, because first you have to break the encryption, then decrypt it, and then analyze it. So integrity forensics is an issue, but how integrity is maintained, if somebody has compromised the integrity, forensics can be done. Because, but again, as I told you, forensics always involves preparation. Forensic always involves provenance or readiness. You must be ready. You must, like your surveillance camera, you are ready. Any customer comes, no problem, I am ready. Whatever he steals, I can easily catch him. Right? So that is something that you can look at. So I hope if you want to find out the integrity has been compromised, so you put some controls on the integrity. So whenever the integrity parameters are compromised, the forensic sensors or the people who are listening or the tools which are listening will immediately say that the integrity has been lost. So the way to do it, right? So that is something which I can do. In security camera are used, which tool we used in forensics? Yeah, any of the security tool can be used in forensics, right? Maybe tomorrow Naveen Chirag Naveen Modi from NIT Goa. He'll be discussing on some of these aspects, and then I think he may discuss some of the tools. So the common tool, any attack tool can be used, and any evaluation tool can be used, right? Some of the tools that are there are the virtual machine introspection tool, VMI. How do I get to install VMI? You have to set up what is called a libVMI. The VMI library tool has to be used, libVMI. So you have a library of virtual machine introspection tool. You set up the libVMI, and then you get access to some of these things, and then you can analyze. So the best tool that can be which tool we use is Inforensic. I think there is a talk by Dr. Anand also on different tools that you will use for forensics. So I will wait till that point of time. Maybe you can take that answer, right? Yeah. How digital forensics can be done, like data leakage or information leakage, is sensitive to company and nation. See, any forensics that you need to do, first you need to be prepared. So unless and until you have some security controls installed, some security tools which are installed, which can actually detect some of these things, you cannot do anything, right? As of now, if you're not prepared, to catch somebody may come into your private cloud, steal your data and leave. Nothing can be done. And most of the times we may be thinking our email software is secure and some of these things are secure. Maybe many times people compromise your Facebook, people compromise your email ID. All these things do happen. You go and rectify it. So maybe many times we think there is a lot of confidential information, how we can leave it in the Google Cloud. But then we don't realize that nothing is secure, right? If somebody wants to do it. Which one provide high security, network security or cloud security? See, it depends on cloud. If it is cloud, then cloud security gives high security. It is understood. Otherwise, if it is not a cloud, then it's a network, right? So cloud is also a network, but then cloud security involves crossing the virtualization layer. So that is the biggest challenge that we need to do. So if you are doing DDoS attack on cloud, it is network security. It is not cloud security, because it doesn't cross the virtualization layer. But if you are doing DDoS attacks on the virtual machines, you will have to obviously cross the parameters. So you have to cross the virtualization layer. So hence it will become DDoS on cloud DDoS on cloud will not be, but DDoS on a virtual machine, DDoS on a hypervisor will be a cloud-based attack, right? Yeah. Hopefully, I've answered all the questions. If there are any, you can ask, right? So let us conclude. Yeah. Can you share real-life incidents? Lot of time. Sir was also mentioning deduplication, right? So many times people observe those duplication mechanisms, right? If somebody sends you a file, and whether you download the file or not, if you don't download the file, people will understand that you already have that file, right? So that's the kind of attacks that are there. One of the common attack that is actually happening is insider attacks. A malicious cloud administrator. If somebody who sets up somebody who sets up a cloud for you, he himself may become malicious. He should be trustworthy. He should have a service level agreement, but he may compromise, and then we never know, right? Somebody asked a question: is Docker secure? Yeah, Docker is a lightweight. Is a lightweight virtual machine. So it will be more insecure in that sense. But of course, it is it is better that we use Docker because you don't really have to use so much of resources. For virtual machines, you need to set up an operating system, use all the resources. But you can maybe you can run 10 virtual machines on a server, and you can run maybe 100 containers, right? Or in fact, even 1,000 containers also. Yeah. It's a lot of questions coming in, right? ML and DL valid in digital forensics. Yeah. ML is okay. DL, I don't think that much of huge data is collected on the cloud, but of course, you can collect a bigger data set and then you can apply deep learning also. But of course, machine learning is a very good tool which can be used on cloud environments, right? Of course, as the size increases, obviously deep learning also will be useful. If you can get a bigger data set, then you can do that. Can you tell me real-time cloud computing attack? Real-time cloud computing attack. Data storage. I was talking about deduplication. Is the other secure deduplication. People do deduplication. People don't copy. Let us say 10 of you have downloaded a movie in your institute and 10 of you are copying onto the cloud. The cloud will keep only one copy because it knows that the same movie has been copied. Same fellows are storing the data. I will keep only one copy of the data. Whenever somebody asks, I will give one copy. So no problem. So that is what I do, right? So I avoid duplication. So I will save some space. So that's called deduplication. But then if an organization is doing deduplication or not is also being observed through side channel attacks. So these are attacks which are possible, right? And a lot of these attacks on live virtual machine migration, while the virtual machines are migrated from one server to the other server, then also attacks can happen. A lot of DDoS attacks can happen. Malware attacks can happen. All these things are live examples. You can just check what are the cloud. In fact, the survey report on Cloud Security Alliance attacks in India, there are a lot of data. So one of the common attack is where you have been using a virtual machine, and after some time you have said, I don't want the virtual machine anymore, and you stopped your subscription. The virtual machine will be deleted. But the virtual machine is deleted, but is your data deleted? The data is not deleted. So anybody who takes the virtual machine space later and digs into the data, he gets access to your data. The link to the data is deleted, but the data itself is still there. Till it is overwritten multiple times, the data still remains. So you need to understand. In deduplication, how to avoid modified signature of the original information. Yeah, these you must go to research papers. On deduplication, there are many deduplication techniques. How to hide that you are doing deduplication, how to hide whether data is copied or not. So these are some issues that you need to understand, and then you can do that, right? So those are things. So please try to go back to the papers. I don't have any ready-made solutions as such, but then you please try to look at that, right? Yeah. Let me come back and complete this. Yeah, okay. We were somewhere here, right? Yeah. After this, we completed this, right? We completed this. Yeah, these are the 9 steps. Creating new architectures, data collection, issues, acquisition, that's the main one. Analysis, the second one. Then anti-forensics, first responders, legal aspects, role management, standards, and lastly, training. So in fact, I will add one more technique here, which I added later. That is what is called attribution, right? I will discuss on attribution also in my next lecture. So data collection, data analysis, and attribution, right? So these 3 are the forensic process. So when you're collecting the data, you can collect the data from a variety of cloud resources like this. So how the data is stored, what are the data, when it is created, all the information that is there that can be collected here. You can collect from private cloud softwares like Eucalyptus, OpenStack, or you can set up an OpenStack or a Eucalyptus software, and then you can create a private cloud environment. Or you have some forensic tools, which I think Dr. Anand will discuss. And then if you have it on mobile devices also, you can have these things like Android, Windows, iOS, all these things. So different mobile phones can be, and finally you have the log collection from. So you can have some of these cloud providers, you can have on cloud environments, you can have on some help from the tools, and some help from the mobile devices, right? So the basic thing is you will collect the data, and then you will preserve the data. Some evidence is collected and evidence is preserved, because when you present in the court will ask what is the source of data, the original data. So the original data must be preserved, and a copy must be taken, and the copy must be analyzed. If you analyze on the original thing, they will say you have tampered the evidence, right? So first evidence must be preserved, and then you must do it, right? Second one is analysis, where you are doing evidence examination, evidence analysis, evidence reconstruction can be done. So the cloud forensic analysis that you do. So you can use soft computing, data mining, artificial intelligence, and machine learning, different types of analysis mechanisms that you can look at, right? Then you can do time frame analysis, data hiding analysis, and application and file level analysis. So these are live problems in the analysis. So when I was doing my research on network forensics, in fact, I have published a book on network forensics by Springer. You can look up network forensics, fundamentals of network forensics, research perspective. It's available on Springer and also available on Amazon. So you can look at that book, where we talk about a lot of analysis technique, a lot of machine learning algorithms are discussed. So you have different mechanisms by which you can try to find out, right? So time frame analysis, when the incidents happened, what happened, where happened, all that. Data hiding, somebody is trying to gain access to all password protected, host protected, encrypted, and compressed files. If somebody was trying hard, then it's an attack. Steganography, without changing the image size, without changing the text, you try to communicate some hidden message inside it. So that is what is called steganography. Application and file analysis, so different files you can try to understand and then try to analyze. So you can have a variety of approaches that you can have: distributed system approach, soft computing approach, honeynet approach, attack graph approach, formal methods, aggregation based approaches. All these things can be done. Lastly, we'll share about attribution. Attribution is to determine the identity of a source of a cyber attack, to understand the attacker's actions, to understand the sequence of events. We talked about reconstruction of events, right? When a murder happens, you reconstruct the scene, how it happened, what you did, and then you make the culprit confess. When he goes to that similar situations, then he reacts, and you look at his face, feelings, and then you can easily identify the digital identity, that is the computer user ID or IP address or the software that is there, whether they are licensed or not, right? So to determine the identity of a source of a cyber attack, where the attack is coming from, is what is attribution, right? There are different attribution techniques. One is traceback of the packets. Then there is host and network observation. The environmental modification also are something. Now let me introduce this aspect called virtual machine introspection, which helps you in trying to understand. So this is the virtual machine introspection application, which is installed on a default virtual machine. So we are talking about the architecture of Zen hypervisor. So the Zen hypervisor has what is called a default virtual machine. Before you create virtual machines, a default virtual machine is created, and all the information to other virtual machines that are created are communicated through the default virtual machine. So what happens is, as you look at this thing, so when you have this virtual machine is created, you can install VMI on that DOM 0, they say. The all other virtual machines are called DOM U1, DOM U3, DOM U3, and DOM U4, and so on. But the DOM 0 is reserved to set up DOM 0. On DOM 0, if you set up the virtual machine introspection tool, it can observe all virtual machines. Now, who will help us? The hypervisor will help us, right? So when a user process talks to the system kernel or the system, it is called a system call. But when the kernel talks to the hypervisor, it is called a hyper call, right? So this is the difference. Communication between hardware or the user to the kernel is called a system call. Communication of the kernel symbols to the hypervisor, it is called hyper calls. So beautiful concept. So you can read what are the hyper calls that are available in Zen and see their usability and functionality and how they have helped, right? So that is something. So hypervisor actually is the one VMI will interact right? First time when VMI gets installed, right? So you have to install it in DOM 0, right? So it is connected. DOM 0 sits on Zen hypervisor, and the Zen hypervisor is able to collect the information and give it to you. So these are virtual machines which are running. These virtual machines are interacting with this, and then you can find out. So variety of data information can be picked up from the kernels, from these things, and then you can find out. So that is virtual machine introspection. So there are three components. The application is there, the API, the application program interface is there, and the guest OS symbol table. These three things are there. You investigate real-time events on the virtual machine. Virtual machine introspection. The word introspection stands for it is observing. Okay, it is helping to change. So that's the VMI application, the VMI API, and the guest OS symbol table, right? So as you see, anything that happens, the guest OS symbol table will have all the entries of the guest OS related information. This is the guest OS. All the information are available on the symbol table, and then here you are running. This is maybe, as you can call it, right? So you have this DOM 0 on which this VMI is set up, and the DOM U is set up here. The DOM U interacts via the hypervisor to this, right? So that is what happens. So you can calculate, you can capture the information of processor register, memory, disk, network, hardware level events using this virtual machine introspection tool. So at the end of this lecture, let us say, sir, what should we do? If that is your question, my answer is first set up Zen hypervisor or KVM hypervisor, create 3 virtual machines, set up open virtual stack, create a network among these 3 virtual machines, and now set up VMI on one of them, virtual machine interaction on one of them, and then try to find out using VMI commands, try to find out what are processor register, what is memory, disk, network, hardware level events, and all that, right? So without the interruption of the monitored VM, you can get that, and you can help in malware collection, malware analysis, intrusion detection, and all. So the tools are libVMI. Right, so the hypervisor attack on the cloud. So what happens? So there is an attacker here. So there are a normal user is requesting a VM to this thing, and the controller node is it is doing the image padding, and then there are multiple VMs which are running the hypervisor. Hypervisor is being the controller which is communicated to the hypervisor. The hypervisor will communicate to the virtual MAC addresses. Before that, the attacker came in and he said, no, we can't compromise. So he compromised the hypervisor. He keeps the control of the hypervisor. So whatever is the response to this virtual machine will be through that gentleman, right? So in cloud forensics, how do I do that? So you have switch 1, switch 2. You have C1, C2, C3, 3. Let us say 3 servers and or the compute nodes, and each of the node will have VM. So that is something that you can look at, right? So there are multiple switches, there are disks. These are storage disks which are separate from the racks, right? But they are all super fast connected, right? So that is something that you can look at. So if you have any questions, I'll be happy to spend some more time. We have, I think, 5 more minutes, and thank you so much. I will share the slides. I will share some tools also, as I thought some tools, anyway, Anand will cover, but I will also share some tools, open source tools, which you can use to work on that. And then we can conclude that part, right? So let me share some, this thing also, the documents that I promised to show you, and then we can conclude it. Yeah, this is the first document that I would like to show, that 9 NIST document, which is about 50 pages, architecture, data collection, analysis, anti-forensics, incident first responders, role management, legal, and okay, so you are able to see this. So let me show you the main document. So this is the NIST Cloud Computing Forensics Science Challenges. So there are about 65 challenges mentioned here. grouped as 9 categories. So this paper I will send you. Please read if you are interested in cloud forensics, right? This is the NIST document on security, which I shared with you. So this architecture is there, and this is part of the NIST cloud computing security reference architecture, right? This is a security reference architecture. You can look at that. We discussed that security reference architecture, right? And then you have this big ITL architecture we have seen. So this is something which we can study in detail. What will be the support and all, just to have an idea about it, right? Right. If you have seen this, then we'll go into the next one. That is cloud forensics adoption. Cloud forensics capability maturity model. Okay, so these are the contents. So these are this is something that you can look at, right? Yeah, this is the cloud forensics capability maturity model. These are the 5 steps, right? We can look at that, right? And then this is the TCA reference architecture. I think one thing is missed out. That is what is that? Cloud adoption. Yeah. Are you able to see?
Yes, sir, we can see.
Yeah, this one, cloud adoption and security in India survey report. Right, let me share again. Because I closed that, right? Yeah. Are you able to see the cloud adoption and security in India report? Of course, this was 3-4 years ago.
Yes, sir, we can view.
Yeah, so this is the thing. Okay, so I will send all these PDFs for you so that you can take up, right? Okay, my book on network forensics. Okay, yeah. Let me see. You can drop me an email, right? Actually, I'm also bound by the publisher, right? Whatever copies, 3 copies he has given to me, hard copy. But of course, if you search somewhere on public PDF sites, you will get the book. The book is open. Some students have already found out, and then you can look at it. Right? Yeah. Any questions?
Dear participants, if you have any question, please ask. Sir, I think all the questions are covered already.
Okay. Sure. Yeah, our time is also up, right? Yeah.
Yeah. So thank you so much, sir, for the detailed discussion on cloud forensics. You have covered, I think, all the aspect of cloud forensics, and I must say that you have covered the formal introduction of cloud forensics. In first 2 sessions, we had cyber unsafe digital forensic that was informative, and then we had detail on cloud security and architecture of that. But this was the first session, and theme of our cloud FDP is cloud forensics. So participants, sir will also take another session on 21st for the attribution in cloud forensics. So we will have another chance to meet sir. Thank you so much, sir.